All right, welcome back, GE101 students. This is your lecture for the second hour of the first week. So it is Thursday and you are about to show up in lab in about an hour. So I'm building this video a little bit before you come. So you already know what we've done in lab. You did an advising sheet. Hopefully you did that one, right? You made yourself an academic plan for 2 years. I'm going to go a little deeper dive into the two programs that we have on campus, the engineering technology program and the engineering transfer program. That is a key piece of knowledge that we want all students to have. So I'm going to go through a little PowerPoint that just goes through some pros and cons of both of the academic systems we have, and that's about it. So this will be fairly short. All right, I'm going to skip the first part, although I will upload this PowerPoint if you want to go through this. The tower to tower tram at Whistler, peak to peak, I think it's called, is a phenomenal engineering masterpiece. So inside this PowerPoint, there's a little bit of information about peak to peak. This is in Canada. It takes you from Blackcomb to Whistler. You can ride it in the summer or the winter. So if you're in that area anytime, you should get on board because it is phenomenal. 9,921 feet from tower to tower. We know there's 5,280 feet in a mile. So this is almost a 2-mile free span. Phenomenal. So if you want to, you can go on to Blackboard, and you're already there because you got to this lecture. But you can open this PowerPoint and then watch these videos on the creation of peak to peak in Whistler, Canada. It's really cool. But what I want to talk about right now, oops, didn't mean to go from beginning, sorry, is the two programs we have on campus. We have engineering and engineering technology, okay? Engineering is known as engineering transfer. For the students that are interested in transferring to a university and getting a bachelor's degree, you have a specific program to follow. It is the engineering transfer program. It's 2 or 3 years or more here. You know, don't feel like you have to pull this off in 2 years. That's not required. You can pull it off in 6 years if you want. So wherever your math is, that's fine. You just have to keep clicking along. You've got to get through your physics, your chemistry, your ENGR courses. That's the engineering transfer courses, ENGR or GE. Now, some of the GEs show up in both engineering transfer and engineering technology. For example, the class you're in, GE101, that's in both. Okay, so 2 years here or more. 2 years or less, actually. Like if you just want to go 1 year here, you can transfer. You'll just transfer probably as a sophomore or maybe still a freshman missing some courses. So you can do that. There's nothing wrong with it. A little better bang for your buck here at Mount Hood. We're cheaper. But yeah, we have students leave after a year. That is not completely uncommon. We have students stay here for 4 years and then transfer, right? Because they're working full-time or they're working half-time and they can only take 1 or 2 classes a term. Absolutely fine. All right. The program is laid out for 2 years here and then 2 years at a university. Okay. You should try to figure out the university you want to transfer to if this is your path. The advising from us is better if we know where you're transferring, okay? It's going to result in a bachelor's degree in civil, mechanical, electrical, computer, chemical, something, right? Computer science. It'll have some title to it, all right? So that is the transfer, and I will, because I think I should jump straight to it and talk about it. Sorry, I'm getting there. Oh man, where is it? All right, I'm gonna blast out of this because it's not working for me. And I'm gonna go back to the internet. I'm gonna pause you for a second. All right, I'm back. So what I've done is jumped into the engineering transfer degree. And this is what we actually did in class. I spent some time in this, but you can see that the fall term, first quarter fall term is supposed to be GE101. Oh, okay, so it's not, right? You're in GE101 winter term, that's fine. Things can be taken out of order if they don't have prerequisites. But fall term, you're supposed to have chemistry 221. So then in the winter, you can take chemistry 222. Those are sequential. So there are sequential courses, and then there are non-sequential, like GE101, not a sequential course, right? So here's the deal. If you're engineering transfer, you're supposed to be at 251 and taking chem, right? And you're supposed to get through that in the first year. So 251, 252, and 261 in the first year, right? And then some GE general engineering courses also. All right, and then in the second year, which would be the fourth quarter, that's another fall term, right? You get a little bit more engineering, but a lot more math. Math is here at 254. And then you start your physics sequence, which is calculus based. 211, 212, and 213. Those got to be in order. Okay. All right. Back to the slideshow. That's engineering transfer. All right. Engineering technology is going to be 2 years here at Mount Hood and then go to work. Could it be 3 years? Absolutely. If you're only taking 2 or 3 courses a term, it could be 3 years here and then go to work. What your goal is educationally is an associate's degree in engineering technology. Jobs can be in the architectural construction, jobs can be in the civil engineering technology, and jobs can be in the mechanical engineering technology. That's why we changed the name to engineering technology. So this individual can apply in many different sectors. The degree is going to train you to function as part of an engineering team. It's going to give you job-ready skills in 2 years, right? And then you're going to work in support of professional engineers, probably doing CAD or testing or problem solving within a team to begin with. And then beyond that, you can go all kinds of different directions. There is a possible transfer to OIT. You would still need to take your calculus and physics, okay? So I do have students that get the associate's degree, go to work, then say, for instance, go to work for Leatherman or Web Steel Buildings or Surveyor, right? And then that company would love you to continue your education and they'll pay for it. So then students take off, either come back to Mount Hood and finish their calculus and physics over time, and then transfer to OIT to get their bachelor's degree. So that is a path that has a bachelor's degree as a goal through engineering technology, but it's really limited to just OIT. Otherwise, you're going to have to retake some courses. Okay, so that curriculum I will pull up next. So this is not that curriculum. So new share, back to so many things open. Let's see where we at. We're right here, share. All right, so we're going to back up and we're going to choose engineering technology now. And we can see right away that the math level is lower. The starting math level is math 95. And then you go math line 111, and then you're done with math. Because the rest of the stuff I'm going to teach you are just job ready skills. Lots of CAD, lots of advanced CAD, both AutoCAD and SolidWorks. Lots of hands-on application of physics in your statics class. That's the study of forces. In your strength of materials class, that's the study of materials. You have a plane surveying class that preps you to work with a survey crew. A lot of different directions you can go. You get AC/DC fundamentals, you get fluid mechanics. It is a wide variety in engineering technology. Lots of hands-on and lots of practical application, because in 2 years you're going to work, you're not going to university. So those are the two programs that you can choose from at Mount Hood, or you can do both. I have students doing both. Maybe their math is not at the transfer level yet, and they still want to take engineering courses, so they pop into my engineering technology courses. That is perfectly acceptable. Again, it's one of the key knowledge pieces that we want you to get out of this class. When I have a quiz, this information will be on the quiz. You need to know the difference between engineering technology and engineering transfer. You need to know the difference basically in the job. You need to know the difference basically in the education. Let me go back to that PowerPoint one more time. And let's see if we can talk about what does a bachelor's degree get me, right? So this is the bachelor's degree for transfer. You can lead teams. You will get higher pay. Obviously, you have a bachelor's degree. You have the ability to become a licensed professional engineer. Engineering technologist, that's not a path that you would take. Now, what is a licensed professional engineer? We'll talk about that on a different lecture. I'll do a whole lecture on it, okay? But that means you've sat for a big test is what that means. And that you've had a 4-year degree, a bachelor's degree. You do have increased job flexibility. What are the drawbacks? Obviously, a lot more school, 4 or 5 years compared to 2, a lot higher math requirement, okay? So more school also means obviously a lot more expense. In engineering technology, what's that get you? Well, gets you to work in 2 years. You are work ready. Good students go to work. Average students also go to work typically because there's such a demand. Poor students, I have a difficult time placing. So that's that. You are going to work in an engineering team, and within 2 or 3 years, you will be a lead on an engineering team, even with a 2-year degree. So be prepared for that. And obviously, you get to work in the field. So the drawbacks, you're going to have less upward mobility if you're at a large company, and that is true. If you're at a small company, you have as much mobility as you want. Like, you will get as much responsibility if you are a good employee as you want. Responsibility brings income and pay. So you're going to start at lower pay than a 4-year degree. That's true. You're going to be 22 to 26 an hour in the beginning. Then from there, as you gain experience and value with the company, you will do much better than that. So, all right, what if happens if I get a 2-year degree and I want to get a 4-year degree later? Well, that usually means you got to pick up that math and the calculus and the chemistry and physics. That's what it means. So if you have the bandwidth in your brain, you should continue taking math, even if you're in the engineering technology field. If not, just get the degree, go to work, and then continue taking your math and physics. And that will open up that bachelor's degree for the future, right? Or just go to work, get some experience, and then go back to school. You know, that's typically what you would have to do if you get the 2-year degree and then you decide later you want the 4-year degree, right? I got my master's when I was 50. So do not think that you cannot go back to school. You can do it. There's no, I won't say there's no problem. There's nothing but problems in doing it later because you'll have a family, a home, you'll need an income, all those things. But you can do it. You can do it. Where do I find out what's in my program or what program I'm in, what classes? That's right on the web. I just showed it to you. Who decides what classes I should take each quarter? That's you. You should be getting advised by me or John Dryden, but it is you. We are self-advised at this campus. You can sign up for the classes that you want, okay? Am I going to check your schedule every term? No, ma'am. No, sir. I am not. But you should sit down with an advisor and you should make this kind of a plan every term, right? Because things will change. It's just a plan. All right, I'm going to stop it here. You guys went and found a few things. I'm going to leave a few things for my next Thursday lectures. So that's it. Have a great weekend. Thanks for doing the lab, and have a good Friday tomorrow.